Hey, welcome back to Education Specialists. Today we're going to be going over a fluid infusion calculation, problem 1. So let's go ahead and get started. Okay, here we go. The problem reads, you are to infuse a patient with 2 antibiotics, one right after the other. The first is a gram of Rocephin. The Rocephin is mixed 100 cc's normal saline. We're supposed to run it over 45 minutes. The second drug is 500 milligrams of Levaquin over a 3-hour period. That drug is going to be mixed in 250 cc's of normal saline. The patient weighs 120 kilos. Question is, which of these rates are faster than the other? And calculate the rates for both infusions. So, when we are thinking of drug calculation infusions versus fluid calculation infusions, and this is going to kind of come home here in just a second. Drug calculations have an amount over a time. Okay, this is just a drug infusion. All infusions are going to have time over it. A fluid infusion calculation. So fluid infusion calculation is going to have an amount of fluid in cc's over time. Okay, this is a volume over time. Okay, fluid infusion calculations. Now, again, both of them are both going to have time, but this was going to have cc's, and this is going to have either milligrams or milligrams per kilogram or something like that. But ultimately, in this particular case, they're like an antibiotic. Some drugs, like we're going to give dopamine, lidocaine, dobutamine, neosynephrine, all those, you might not give that whole bag. But in the case where you are going to give the whole bag, like you're going to give a gram of Rocephin in 100 cc's, so you don't have to really worry about the gram right now. All you need to worry about is how fast to give that whole bag, because they're getting the whole bag. So in that particular case, let's take a look. So Rocephin, we want to give 100 cc's. And we run it in 45 minutes. Don't let this 45 minutes scare you. We can run, and the time there could be anything. You can, if it's going to be, 5 hours, then do 5 hours times 60 minutes, 60 minutes, and then you can put that whole minute count there. For instance, if you're going to do 2 hours, then it would be 120 minutes here. Don't let, when they give you this, to spook you. We're going to give this whole bag, which has a gram in it, by the way, 100 cc's in 45 minutes. Then we can do one of two things. Either we can do it the ambulance way, or we can do it the hospital way. Let's go with 100 cc's. We're going to do the ambulance way. Then we're going to do our drops, our drop set. So we have a 60 drop set here. You could have a 10 or a 15 or a 20. If you have a 60 there, of course, it's always cc. So let's go ahead. Cc cancels out. What we're left with is drops per minute, and that gets us 133 drops per minute. Now, if you want to take that into put it per second, then divide this 133 by 60, and you get somewhere around 2.2 drops per second. So you can eyeball it. Now, if we're going to give this same rock 100 cc's in 45 minutes, but we're in the hospital, so we want to use a pump set. So instead of a drop set, then we want to eyeball a pump set. We go 60 minutes is in 1 hour, because what do we want in the hospital? Cc's per hour. Minute cancels. We're left with cc's per hour. And that gets us, of course, 133 cc's per hour. Okay, these are the same numbers, same values. A little hint there of my hybrid method for calculating fluid and drug calculations. We can, if you haven't heard about that, or if you have and you're interested, there are classes forming now and in the future. You can also request it on my website if you're interested in learning how to do that. But back to this problem, we have 133 cc's an hour and 133 drops per minute. If you divide that by 60, then you get 2.2 drops per second, so that you can eyeball the drip chamber. Okay, so let's do the second part here. Levaquin is mixed in a 250 bag, we want to give 500 milligrams. The patient weighs 120, but that's just a throw off because we're doing infusions of fluid right now, not necessarily of drugs. So we want to give this 500. This whole 500 milligrams is going in, so we don't have to worry about that right now. We can just focus on the 250 bag and how long? 3-hour period. Okay, no problem. Let's come here, and we go ahead and set us up on. Excuse me. Let's back it up because we want to give 250 cc's in 3 hours. So 3 hours is 180 minutes. Now, if we're going to do it in the ambulance, we'll be here. Hospital will be here. Again, if we're doing the ambulance, then we need a drop set because we don't have pumps, and we have to just kind of eyeball things with a drop set. So again, let's use 60 drops, and a drop set is predicated by the number of drops that makes up 1 cc. Okay, this equals, and we'll go ahead and cancel. We have cc's that cancel in this case. What we're left with, yep, there's drops per minute. And if you notice, this will get us 83 drops a minute, or if you divide that by 60, then that gives you somewhere around, let's just do it real quick, divided by 60 is 1.3 drops per second. Okay, so if you're going to eyeball, it'll be a little faster than 1 drop falling per second. In the hospital, or ICU, or ER, where you're going to use a pump, or an aircraft, or in the ambulance if you have a pump, still no big deal. 100 cc's, 100 minutes, 250 cc's in 180 minutes. Well, we're going to use a pump set, so let's convert minutes to hours. There's 60 minutes always in 1 hour. And then we'd go ahead and scratch out our minutes and minutes. What we're left with is cc's per hour, and that gets us the same number because it's 250 times 60 divided by 180. Same thing here, 250 times 60 divided by 180, and that gets us 83 cc's per hour. So you can see here that it's very simple. I'm talking about fluid infusions, but you could use this for anything. Luckily, in an antibiotic world, or in an antibiotic administration, usually that's IV, you're going to give that whole thing, that whole bag, because it's one full dose. But let's say that somebody wants you to give, let's say we have a liter bag here of saline. Okay, they want you to give 500 cc's of this. 500 cc's in 10 minutes. So let's say that's just a bolus. We want to hurry up and give that 500 cc's in a bolus. And then we want to give this next 500 over the next hour. Well, this is just two simple equations. We want 500 in 10 minutes. And then whichever you want. If you want to do it in drops per minute or cc's an hour, just choose. So in this case, let's just do cc's per hour, so that'd be 60 minutes in 1 hour, and then the last one would be 500 cc's over 60 minutes, with 60 minutes per hour. You can see easily here that cancels out, that cancels out. Minute, you're left with 500 cc's an hour for the bottom, and 60 times 500, 60 times 500 in the calculator equals 30,000. Divided by 10 equals 3,000. Oh, not drops. That's 3,000 cc's per hour. There we go, cc's per hour, because minutes cancel out, cc's per hour. So you'd have to run this at 3,000 cc's per hour until you get to that 500 mark. Once that's done, you just start another infusion with 500 cc's an hour, and over 70 minutes that whole liter could go in, because 10 minutes plus 60 minutes. There you go. Thanks for joining us. Check again medspecs.com for future problems. Good luck calculating.